Hi guys, welcome to today's video. Today we're going to talk about closure properties of context-free language. Introduction to context-free languages. Context-free languages, also known as CFLs, are defined by context-free grammars. They are essential for programming languages and compilers. Understanding the properties helps in language design and parsing techniques. Context-free languages is CFG, which is usually denoted by G is equal to VTPS, where V is a finite set of variables and V is also the search symbol. T is the finite set of terminals and T is the V which is 0. When P is a finite set of reproductions or rewriting rules, such production is also of the form. Closure properties. Closure properties refer to the ability of a language class to remain within the same class after specific operations. For context-free languages, these properties dictate how CFLs interact under operations like union and concatenation. Knowing closure properties is important for understanding language transformations and constructions. Union of context-free languages. The union of two context-free languages is also a context-free language. This property allows for the combination of multiple CFLs into a single CFL. It is instrumental in designing languages that can accept various types of inputs. As you can see by the diagram, inside recursively enumerable functions are the context sensitive, under which is the context-free language, and under which is the normal regular language. Intersection with regular languages. The intersection of a context-free language with a regular language is a context-free language. This property is used for recognizing patterns that can be described by both CFLs and regular languages. It facilitates the construction of parsers that need to handle specific regular constraints. Concatenation of context-free languages. The concatenation of two context-free languages is also a context-free language. This means that if L1 and L2 are CFLs, then L1, L2 is also CFL. This property allows for the combination of language elements in sequence, enhancing the expressiveness. Clean star of context-free languages. The clean star operation applied to a context-free language produces another context-free language. This property allows for the generation of strings of arbitrary length from a CFL. It is crucial in defining languages that require repetition of patterns. Intersection of context-free languages. The intersection of two context-free languages is not necessarily a context-free language. This property highlights the limitation of CFS in handling certain complex patterns. It indicates that more powerful language classes, like context-sensitive languages, may be required. Complement of context-free languages. The complement of a context-free language is not guaranteed to be context-free. This property implies that CFLs cannot completely represent all languages, especially their complements. It suggests challenges in certain computational problems where inverse recognition is needed. Closure properties summary. Context-free languages are closed under union, concatenation, and clean star. They are closed under intersection complement. Understanding these properties is crucial for utilizing CFS in computational theory effectively. As applications of closure properties. Closure properties are pivotal in compiler design and syntax analysis. They assist in defining and recognizing programming constructs effectively. Closure properties also aid in formulating algorithms for language processing tasks. Example of union operation to understand the function. Let a1 be a to the power of n b to the power of n, which is saying that n is, should be greater than or 0 equal to 0, and let l2 be b to the power of n and c to the power of n, and should be greater than 0, 0. The union L1 UL2 will show us that it shows the union of a to the power of n, b to the power of n, union with b to the power of n, c to the power of n is context-free. This shows the flexibility of CFS in combining different structures. Example of concatenation. Consider L1 is a to the power of n and n should be greater than or equal to 0, and L2 is b to the power of n and should be greater than or equal to 0. The concatenation of L1, L2 gives us a to the power of n and b to the power of m, which gives us which shows us that n, comma m should be greater than or equal to 0, which proves that it is context free. This example illustrates how CFLs can be combined to form new languages. Limitations of intersection. If L1 is a to the power of n, b to the power of n, which indicating n should be greater than or equal to 0, and L2 is b to the power of n, c and c to the power of n greater than or equal to 0, the intersection is not context free. This limitation index indicates that CFLs have boundaries in handling certain language patterns. Understanding these boundaries is vital for computational theorists and language designers. Importance in computer science. Closure properties of CFLs are foundational in automata theory and formal languages. They influence the development of parsing algorithms and language processing tools. Recognizing these properties informs the design choices made in programming language development. Conclusion. The closure properties of context-free languages reveal both their strengths and limitations. They are essential in a variety of applications, particularly in computer science. Further exploration of CFLs can lead to advanced in language theory and computational applications. And that brings us to the end of the video. Thank you for watching.